Welcome to the second series of the Biotech Podcast. In this series, our aim is to introduce you to a host of researchers working on problems within the agricultural setting. Our hope with this series is to show that there is room across the agricultural sector for people with a variety of skills. Agriculture sits on the precipice between the natural and engineered worlds, and will have a huge role to play in some of today's greatest challenges. It is said that the more you know about the past, the better prepared you are for the future. For this reason, I thought it important that we delve into how agriculture has changed over the past century, what lessons we can draw from this change, and how we might expect agriculture to change as we move into the future. With me to discuss the history of agriculture is Dr. Helen Curry. She is an associate professor in the history of science and technology at the University of Cambridge. Helen has a particular focus on the environmental and agricultural sciences. As such, there is no better person to lead us through this history to see what insights we can gain. Now for my conversation with Dr. Helen Curry. Can you take us through some of the major changes you've seen over the past 100 years in how we produce food?
Great question. Obviously a big question, but one that's important to answer to sort of lay the groundwork. So if we think about the last 100 years, that takes us right to the early 20th century. And just thinking now about the global north, about the industrialized countries in Europe and the United States and beyond, some of the big changes in agricultural production have to do with the increasing use of machinery in food production, also the rapid takeoff, actually in kind of incredible production of synthetic nitrogen used in fertilizing crops. And then I'd say there's been a shift in the circulation of crops in terms of where they're produced versus where they get consumed. So people talk about food miles a lot, and food traveling around the world is not new in the 20th century. Colonial infrastructure before that certainly meant that meat and other crops or other food products were circulating, but the scale at which that has happened in the 20th century, intensified by transoceanic travel and other mechanisms, has meant greater global circulation of agricultural products.
Mm-hmm. Is that essentially feeding demand in certain places, or what is the thing that's caused this massive increase in the what people are consuming globally, and what were they consuming beforehand?
So I think we can think about agriculture as having been not local, but much more regional in terms of how it was organized. So people would be eating more seasonally in terms of what was produced, say, at the end of the 19th century, and would be eating much more the products of their local region, with the exception of some global commodities, right? So with the exception of sugar, which was a product of empire, for example, when it was brought back to the UK, and has always been a long-distance agricultural product. So, but for the most part, those products were the exception rather than the rule.
So you've seen these changes in machinery, fertilizers, and where foods are consumed. Are those the things that have essentially shaped the face of what agriculture is today, or are there other things within that 100-year period which we should take note of?
Yeah, so it's really hard to pinpoint any one thing, like changing consumption patterns or changing demand, as being a driver of some of these changes. I think overall, we might say that dependency on fossil fuel and a willingness to use ostensibly cheap fossil fuels to drive agricultural production, that led down certain pathways that have shaped the way that we grow food and also the foods that we eat. But in a way, and maybe even that answer points to the fact that the system is, the agricultural system is embedded in a much larger economic and political infrastructures, and that we can't think about what causes changes in agricultural production without thinking about that larger set of conditions and circumstances that shape what's possible. So just to take the point of nitrogen fertilizer, prior to the early 20th century, fertilizers were already being extracted and imported in large part from South America. So I don't know if you're familiar with the idea of the guano islands.
No, this sounds interesting.
The principal source of soil fertility in industrializing Europe in the end of the 19th century and the early 20th century was bird excrement mined in South America and shipped to Europe to restore fertility to soils that were overworked.
This was prior to the Haber-Bosch process. They used bird shit basically to okay.
And so you had an organic source of fertilizer, but one that these immense deposits of kind of fertile, rich substances to add to soil were depleted fantastically rapidly. Right? And so even in the early 20th century, having only fairly recently discovered these kind of riches of fertilizer, there was a crisis of soil fertility. Where would that come from? And so the Haber-Bosch process obviously tied up with the production of it's being scaled up to the levels that then transformed. Agriculture was tightly connected, not just with the soil fertility crisis, which might have driven the research, but also with the needs of military production and using nitrogen in weapons production in World War I. So if we look at why nitrogen fertilizers took off in the way that we did, it's actually really intimately connected with military strategy in World War I, right? And so arguably without that impetus, there wouldn't have been the overproduction of nitrogen that then had to be repurposed in new ways.
Which got put into... So the Haber-Bosch process wasn't also used in the making of like munitions. It was actually that it came about at the same time as nitrogen being used in munitions? Or?
No, sorry, I should clarify there. It was central to munitions making. So there was the demand for the nitrogen, right? And so... or nitrogen products. So, I raise that example not to say anything specific about fertilizer use, although that's part of the story, but to situate changes in agriculture in much
global context.
Yes.
It sort of mirrors things that are going on in the outside world, and then. Yeah, so you've always got changes from the outside world which will have an effect on agriculture. You can't see it in isolation type of thing. How, in terms of the sort of pressures of the outside world on agriculture today and the problems that you would say are potential or have been arising for the last 30 years, can you talk to any of those? Can you give your opinion on what they are, where the new pressures are coming into this? Or the catalyst for change, I suppose, is a way of putting it. But where are they?
Yeah, I think there's a lot of researchers situated in science, especially and economics and political science, who are probably better equipped than a historian to characterize these. But I think when I think about the sort of long trajectory, things that people point to are massive disruption of the nitrogen cycle, also our running out of phosphorus supply. So we have, over the past 100 years, become dependent on certain inputs that we may not have going forward, and we need to think about that. I think the structures or the patterns of agricultural development in the past 100 years have been very unequal in terms of the outcomes that they produce for different people. So we talk a lot about, resolving hunger and resolving poverty in part through empowering farmers, right? We've been working at that a long time, and the institutions that we've put in place don't necessarily deliver what they say they will. And so I think that's another agricultural concern or problem with agriculture. How do we resolve social inequity through the
on a global scale rather than just, you were talking like sub-Saharan African farmers versus farmers in the West type thing, is that right? Or...
That's true, but if you also think in the UK context, there are a lot of people who tie the ways that we produce food now, the way that we process food now, to some of the major health inequities that we see in the United Kingdom, right? Especially in a time of COVID, certain underlying health conditions that might be linked, for example, to a person's weight, then are intensified. And if we look back to what, the sort of whole food environment and how that's shaped by the way that we're producing food, what foods are cheapest to make and eat. So that's another, it's not just a global problem, it's also something local here.
A national as well as international problem, basically.
I could also, I was going to say, I can speak to something that is closer to the things that I've been researching and thinking about recently, does have to do with the biodiversity in the food system and the diversity of the foods that we eat. And so a lot of people pinpoint an area of concern being about homogenization of diets, about homogenization of agricultural crops in terms of what we grow. And I think the issues there are not as straightforward as we're losing biodiversity, because we're also gaining diversity when we breed new crop varieties, so we have to be careful in the way that we think about calculating what it means to lose things. But I think it's safe to say that lots of people are concerned about whether we're putting ourselves in a vulnerable situation by allowing at least our crop production, our livestock production as well, to have gone down a path of ever narrowing diversity.
The sort of mechanization almost within the sort of sphere of crops.
That's a good way to think about it.
In terms of the homogenization part, is that in part influenced by this increase? So you talked about three things being the machinery, fertilizers, and the circulation of food. The problem of homogenization, is that resulting from stuff like fertilizers being used and these crops work better with fertilizers, or what causes it?
Yeah, as with other things, I think it's certainly multifactorial, but there are ways to draw connections between, say, a mechanical tomato harvester and the demands it makes of the tomatoes that it picks, that they be of the same height, that they ripen at the same time, that they be roughly the same size, that they be sturdy enough to not smush when picked. And so that certain kinds of mechanization drive certain kinds of biological standardization. With respect to fertilizer use, some of the first crop varieties or sort of families of varieties, if you will, to go truly global, were the wheat and rice varieties produced in the 1960s in conjunction with what we call today the Green Revolution. But so the product of international agricultural development and research, based on a few original strains, adapted for different contexts, say Mexico versus India, but sharing considerable genetic material, and then widely promoted and circulated in terms of their productivity. And their productivity of those particular strains of the so-called miracle rice and wheat varieties of the 1960s and 70s, their productivity was linked to their responsiveness to nitrogen fertilizer. Okay. And so they came as part of a technological package where
you couldn't just have the wheat, basically. You had to have the wheat plus fertilizer to get the final product.
Exactly. Plus the irrigation, and plus the government subsidies that let you borrow money or have the resources that you needed. And so a whole kind of package of inputs and support were essential to the high yieldingness of the varieties. But so absolutely the availability of cheap fertilizer then made it potentially more beneficial to have a crop variety that responded to fertilizer use, which then drove crop varieties in the direction of being fertilizer respondent, if that makes sense. So again, this sort of pushing in the same direction in terms of what kinds of things people are growing would be linked to a change that ostensibly seems unrelated, right?
Yeah.
In terms of fertilizer could work for any plant. Well, actually, it doesn't work in the same way for every plant.
Yeah, you're actually better using it for like a dwarf variety of wheat than you are for, like a bean or something like that. In fact, you probably wouldn't put any fertilizer on that sort of stuff. But how big an effect did the Green Revolution have on the face of farming globally, in your opinion?
That is a fantastic question. And I think it's one that actually people are still debating. There are, I think, active camps of scholarship that say the changes that came about around the time of the Green Revolution and that were extended later with different kinds of agricultural interventions, that those saved lives by making it possible to produce more grain on less farmland. There are those who say it destroyed lives by dispossessing some farmers from the land that they have, or introducing styles of agriculture or kinds of crops that weren't appropriate for their cultural or economic context. And
where do you sit? Yeah.
I think there's probably some truth to both of those statements. I think that it is uncontrovertible that the technological package of the Green Revolution had ill effects for some people, or had differential effects. It benefited some very much, may have overall increased the productivity of agriculture in particular places, but at the micro scale, not everybody won, right? And so trying to think about, the lesson of the Green Revolution shouldn't be let's have another one. It should be, how do we get down to the differentiating between what happened for some farmers and what happened for others, and how do we take those lessons and move with them responsibly forward?
How good do you think we are at doing that? I mean, so I suppose a lot of the people who have an effect on things like the future green revolutions will be quite often the researchers who are doing, they create some new enabling technology, like your dwarf variety of wheat. How good are people doing that research at actually taking those considerations into account?
I think overall, probably the track record of sensitive technological development, maybe on the whole, is lacking. But I do think, especially in recent decades, for example, the International Agricultural Research Centers have integrated agroecology. They've integrated in programs specific to gender, for example, to take into account what changes mean for different groups of people, right? And so as long as we're building research teams and operations where people who have a lens onto those different, someone who knows the social context along with someone who knows the ways in which certain genes respond to certain kinds of conditions when included in a new variety, right? I think the ideal is that you want those two groups somehow together, or both involved, right? It's safe to say probably there's not as good a track record of that, for example, in international agricultural research as we might want. But I do think that is on the agenda, and so
I suppose a lot of the time you can actually almost look at it a lot of the time, so the scientists can, they can develop their new enabling technology. They don't necessarily have to be the people implementing it. So quite often those decisions, I suppose, are made between the stakeholders and your policy makers rather than between the scientists and the policy makers and the stakeholders a lot of the time, or is that incorrect?
I mean, I think it's probably dangerous to think that any science is free of politics.
Yeah.
And so the real victory, I think, is to see that even the scientists who's just out there, seeing what they can make a wheat variety do, that is already a political act, right? Making decisions. Yes, yeah. And so I don't think it is just a matter of doing the right thing downstream. It's a matter of starting at the starting point with the idea that what one does is, that all of the actors that we're talking about historically and in the present are embedded within larger political economic structures that create kind of limitations on what they do, right? So one of the things...
Yeah. Also starting off with the problem quite often you're starting off the scientific search with a problem rather than just, being curious about what you're going to make. And if you don't have those stakeholders in from the beginning, so if, let's say, you're not actually talking to people in sub-Saharan Africa, then one, you might not be working on solutions that are important to people or will work within their context, and you sort of potentially end up in a bit of a situation like an example is UTI research, I would say, is an area of science which is very urinary tract infections are very under-researched. And they shouldn't be, and there's beginning to be work to get rid of that stuff, but I would say a lot of that is potentially due to the stakeholders who are deciding the lines of research at the very beginning, and just maybe a slight an imbalance in that.
Yeah. I think sociologists of science refer to undone science as this kind of example. What are the things we should be thinking about and that people need us to be thinking about, but there isn't the financial incentive or the state incentive to go after it.
Or even the people talking to the scientists in the first place to incentivize the problem. I mean, a lot of the people looking at this stuff don't know there's a problem out there. And I think a lot of the time if they knew what the problem was and how it affects certain people, then they'd be more willing to go and work on it and go and begin coming up with solutions for...
But I think there's one of the major trends, and maybe this is something else I would point to as a change in agriculture in the past 100 years, is there has been a wholesale shift in terms of where the funding for research comes from. Okay. So in the early 20th century in the United States, the government invested in developing an incredible research infrastructure. It was pork barrel politics through and through. It was getting subsidies to Midwestern states, right? But it produced built up the land-grant college infrastructure, the infrastructure of state agricultural research and extension stations. A similar process of building agricultural research infrastructure was happening here in the UK, right? So the early 20th century is when you get the NIAB, that's when it traces its history to. You have what would eventually become the John Innes Center. You have the Potato Virus Research Station, right? So you have state money going to solving agricultural problems, figuring out ways of production that respond to the needs of agricultural constituents. Starting in the 1970s, starting a bit earlier, but with increasing intensity from the 1970s onwards, that has been not necessarily dismantled, but gradually hived off to private industry. So our agricultural research today is by and large driven by the questions of private companies, whereas previously those companies certainly had a stake and a say in research, but it was publicly funded and publicly determined. And so, I think about this question of, the undone science. It's about people asking the questions. Well, if the people holding the purse strings for, what questions get pursued fundamentally have their the financial bottom line foremost in line, there's only a subset of questions that are going to get asked. So I think that's another historical trend that significantly limits the possibilities of today.
That's really interesting. And you almost get, you can see your almost over-dependence on productivity-focused agricultural science, I would say, is something that has existed up to this point. We know, obviously, far less about the stuff to do with environmental services than we do know the stuff to do with how to make better varieties of wheat for the purposes of large-scale production of foods and mechanizations of foods. I love the expression pork barrel politics. That's I hadn't heard it before. I have to admit it's a new one, which I think I have to.
Probably an Americanism. Sorry.
No, I love it. It's great. Yeah. So, in terms of the sort of these most of these shifts that you're talking about seem to have gathered large sections of agriculture and kind of got them to do the same thing in different parts. So you've got like the almost centralization to a certain extent of a lot of the agriculture we do today. What are the benefits and drawbacks of this that you see, whether it be in the fertilizers we're using, how crops circulate around the world, the machinery we're using, or the actual just diversity of crops and the things we're deciding to grow? What are the effects of this, and do you think that tells us anything about what agriculture in the future might look like?
Yeah, I think even the way in which you just described that in terms of centralization, I think something a lot of people who work in kind of food system scholarship talk about is the kind of consolidation that has happened in food and agriculture industries. So the classic example in many ways is the seed industry, which since the 1970s, so within the space of about 50 years, has gradually come on what used to be actually a quite diffuse set of public and private seed producers has become basically three industrial monoliths that operate globally, right? So those are the big ones, and then there's slightly smaller but still enormous groups associated beyond that. But you might think, okay, there's an advantage of scale there. Maybe they're delivering seeds more cheaply. But we might also think that really there's a concern there about power, right? That's an immense amount of power that perhaps a very few sets of boards of directors have ultimately over significant input into global food production.
Essentially what we eat.
Right. So we might think for various different reasons, we might think that's an undesirable situation. We might think, well, are those firms going to be as responsive as we need them to be to whether those are environmental pressures? Are they going to be as responsive as we want them to be to concerns about social justice? If we are interested in equity and diversity, is that what those companies can do? Or are they really good only at producing cheap seed, right? So if we want to have a different priority, how do we actually act on those different priorities, right, without other actors in the system? So I think that's one thing I would point to as a concern.
Do you think that maybe there's a potential that cheap seed has sort of won to an extent out this debate because cheap seed is what people value most?
Yes, I think that's a really interesting point. And I mean, if the people that you're talking about are farmers producing...
Even final consumers, I mean, the price of a loaf of bread in the supermarket is something that's I'm pretty sure it's tracked at like government policy level, I thought, but maybe I could be wrong with that.
No, I think that's a great point, and it's one of the main critiques I think that comes back against some of the alternative agricultural agitation. I would say that we had the activism around food and around seeds, is that ultimately, is it better for everyone if food is just as cheap as possible? I think what that misses is that a lot of things within the world of food and agriculture that we think of as cheap are only cheap because we are not actually paying for the externalities, right? So the carbon footprint of fossil fuel-based agricultural production is generally not factored into what we pay for cheap bread at the grocery store. And if we were paying the full cost of a quart of milk in terms of what feeding that cow soy from Brazil has cost in terms of losing the rainforest and not having the carbon sink anymore, if we factor all those elements in, we might realize that it's not as cheap as we think it is.
Yeah, the sort of almost, I mean, that's such an interesting idea, and I keep envisioning it in my head as almost taking out an environmental loan, and then as in taking out a loan against the environment on, having cheap food today, but have we gone too far have we been too frivolous with the budget that we have at hand, and is this the point that we're going to have to start repaying some of that environmental loan and essentially get real with that within the agricultural system? Going all the way back to inequities on a national level, the other week I was speaking to someone who focuses on nitrogen fixation in cereal crops, because a large part of that is because it costs more to buy fertilizers in sub-Saharan Africa than it does in the UK. Why does it cost more to buy fertilizers in sub-Saharan Africa than it does in the UK? It seems, for me, I'm like, he's working on really incredible stuff. It's really cool. But why the hell aren't there fertilizer factories in those parts of the world yet? I would have thought that market demand can begin to be created, or that's an obvious sort of... It seems fairly obvious that you put fertilizers out there and you begin to get them. It allows people to grow more and start helping themselves out, but I don't know.
That's a tough question, and I don't really have an answer for it, sadly. I'm not sure what the circumstances of that particular context.
Okay, fair enough. So a lot of the work you've done, and you've written quite a bit about it, is on the context of genetic engineering and what it can potentially mean, or how it might potentially change agriculture. Can you tell us a little bit about Genes Made to Order, your book, what it's about, and why you think this new age of genetic engineering is potentially very important for an inflection point in the history of agriculture?
Yeah, so the book that I wrote about the history of genetic engineering starts at a moment in time when I think most people would not think of starting it, which is in the late 1920s. And that's when the phenomenon of X-ray induced mutation was first confirmed. So that's the idea that you could, through the radiation produced by an X-ray device, an X-ray tube, you could expose a plant and it would generate a genetic change, and that you might then, as some breeders imagined, use these randomly produced genetic changes to develop new crop varieties. So you might ask, well, why was that even thought to be a good idea? The notion was that finally here's a means of intervening in the stuff that nature has given us over time, the stuff that evolution has produced, to try and produce changes faster, maybe changes that evolution didn't bring about over time in various different crops and plants. So it was imagined by inducing mutation that you would speed up the process of breeding.
They must have had to have done that randomly as well, because you were still at a point where they didn't even know what they were changing to produce the mutations they're
Yes.
looking at, which is weird.
Absolutely. And so the big lesson of the history, there are several different technologies you can tell this story about, all which rely on randomly induced mutations, is the disjuncture between how much was hoped for and how much was promised of new genetic technologies when they were introduced, in comparison to the the actual payoffs on the other side, how little change happened as a result. And I think the temptation is to say, oh, well, those were just failed technologies, right? Those didn't deliver on what was promised. But what I would say to that is that if we look at the comparative case of recombinant DNA, so what we refer to as genetically modified, but the idea of transgenic changes as opposed to the even more recent gene editing. But just the class of recombinant DNA or transgenic crops, we might say, oh, those delivered. We grow tons of those around the world today. So it might not, X-ray radiation didn't make a big difference, but transgenic radiation did. Except that I think I would go back to the comparison of promises. What was promised from the new transgenic crops when they first seemed conceivable in the 1970s? They were going to fix their own nitrogen. They were going to resolve nutritional deficiencies. They were, the kind of host of agricultural wonders that would happen through this new tool, versus, basically we've commercialized two traits, and we've done it across crops. There's BT, right? So crops that are resistant to certain insect pests, and there's Roundup Ready crops, and those ones are herbicide resistant. They're widely used. They've clearly made a big impact on agriculture. Have they delivered on the promises that were made for this technology? And there's a whole host of reasons why they haven't, which we could talk about. But I think, for me, the lesson from looking at the long history of genetic engineering, starting with these tools in the 1920s and 30s, and then thinking through what we're dealing with today, is like, we should be careful what we promise, and we should make sure that the systems and the political, economic structures in which they're embedded are ones in which we can use those technologies for the things they might be good for, right? That the technology alone, that can't necessarily always deliver what it promises.
Almost looking at things from a historical perspective, what we have promised in the past and where those promises have ended up, it would naturally be the case that one would be a bit of a skeptic about what is being promised today. I love that. That's a great angle.
The science reporting of the past to give you a pause about things.
Why? What is it?
I think, kind of hope springs eternal, and I think that's probably good. But seeing it always, seeing the same promises and the same claims, there's a whole genre of biohype, I would say, in which it's, the promises of the new biology, which is not a new thing. It's a very old thing. Those claims tend to circulate around some of the same things. So, for example, the historical figures that I was really interested in the 1920s and 30s, they talk all the time about accelerating evolution. And when I started the project in the early 2000s, it was really fascinating to me. I thought, well, we don't really talk about accelerating evolution anymore. It's all about, in a way, like circumventing evolution. Transgenics was all about mixing species that could never have mixed, right? And it has been so interesting in the past, 5 to 7 years with the new gene editing technologies. Accelerating evolution is so frequently what's talked about, and how finally we're going to be able to accelerate evolution because of these specific ways that we can intervene in a single genome and push it forward. And I think, we have been there before.
Yeah, interesting. God, fair enough. I was so excited, and it always tempering one's excitement and making sure that you realize that. I think it's actually a hopeful message, to rephrase it, is like, there are always problems to be worked on. So if you're someone who's interested in sort of like going into these sorts of areas and you care about these problems, even though some people might say, oh, it's solved, it's probably not most of the time. There's probably still more things that need to be done so that you're, what did you say, a fountain of, what was it? It's like a second expression during the thingy. It was a hope springs eternal. So I mean, linking what you've just talked about, so the difficulty of, I suppose, innovation in these areas and actually how much more difficult these problems are, or how we overpromise stuff. You've also done quite a lot of work with seed banks. Mm-hmm. Do you think the fact that so if you had great genetic engineering and we knew how to do this stuff, we wouldn't really need seed banks. Do you see seed banks as important, as being almost more important, again, like an insurance policy against sort of these technologies not working and what we're doing at the moment within the agricultural setting not really working?
Yeah, great question. So seed banks have their origin as tools for plant breeders. I think that's what you're pointing to, okay. Right? So the first big collections of seeds in long-term storage were put together as basically a kind of library of genetic potential for breeders to work with in terms of developing different kinds of crops for different regions of the world, or to meet new kinds of demands. And that was the imagination behind them. In the 1960s and 70s, they transformed to also much more significantly be about trying to protect things that might be disappearing forever. So then they ended up by the 1960s and 70s having this kind of hybrid purpose, one which was just to be an immediate resource for breeders, and another one that was to make sure that different genetic combinations that had arisen over time stayed the same, so that a land race of wheat developed in a part of Turkey might still be available for people to access and think with in the future.
So if there was some trait which was good but we want to bring back, it's sort of where history gives us lessons that we can use in the future type thing.
In a way, yeah, absolutely. Written in genomes. I like that. But I think your question, I think, assumes that something like CRISPR-Cas9 would give us the ability to engineer whatever trait we wanted. So who needs that seed?
Yeah.
Right? I mean, I think that assumes that we have an awful lot of knowledge. Yeah. So I think, my own instinct is to say, yes, we should absolutely have collections. We should have seed bank collections. But I think it's important to also put a caveat on the idea of seed banks as insurance policies. One thing that I have learned over the history of, over my own experience of researching the history of seed banks, is that the kind of insurance policy initially imagined for these institutions would be, we would build sound structures, we would have well-equipped staff with high levels of training that would maintain, because...
Is this for the seed bank?
For the seed bank, right? Because you can't just put in a seed and then walk away and expect to come back 20 years later. Okay. Some seeds need a lot of care, right? Yeah. They don't last that long in storage. And so you would have a kind of well-resourced institution, and you would have well-resourced staff. The history of seed banks has suggested that most states and institutions have been unwilling or unable to make the resource investment needed to seed bank really, really well. And that has led us ultimately to a situation where what's seen as the security measure for seed banks is creating copies of the collections. So in case they're not cared for well somewhere, there might be another copy somewhere else.
So you replicated across, not just like in the same seed bank, but actually across geographical locations.
Yes, exactly. So the classic, the sort of media example of this is the Svalbard Global Seed Vault, which is an institution north of the Arctic Circle, which houses copies of the world's major seed bank collections in the permafrost. But it is a copy.
In smaller numbers, I can imagine, or then most of the other seed banks have it. So the other seed banks might have a larger proportion, they have a smaller sample.
That's right. So they would have a sort of subset of the numbers of seeds. But I think it's really important to note that when the Svalbard Global Seed Vault and its, the institutions behind it describe it as, the great insurance policy, that's an insurance policy based on seeing copies as the route to security, which maybe makes a lot of sense in a world where we back up our computers and then we think they're safe. Yeah. But, I think it's worth pausing to think, a well-resourced institution with well-resourced staff versus a copy in an inaccessible location? What kinds of security does each of those institutions promise, and which one do we really want as our insurance policy? I mean, people might come down on that question differently. I sort of know where I do. But so I think, it's important to note that seed banks as insurance has shifted over time as well, in part because we have seen them as not great insurance because we're not willing
to fund them.
Where do you come down on that question?
I mean, I think, and this goes back to some of the things that I was saying before. One of the things that I think, having researched the history of agricultural research, is that public funding for agricultural science across a number of domains should be increased. We should take that back as a public service. It shouldn't be provided by private industry. And that would include, I think, better publicly funded seed banks. But also, one of the reasons that seed banks were underfunded and was in part linked to their not being used as much as they might be as resources for breeders. And that had to do with lack of resources to fully catalog and characterize the things that were in them, right? These are tasks that cost money, that take time, but the investment that the payoff of that investment would be knowing more about what the world's diversity is and being able to make use of it in really smart ways. I think one of this kind of sort of promising outcomes of the current moment is the idea that high throughput genomic sequencing might allow us to at least get the genomic information of seed banks better known. So to do characterization a little bit more affordably. We still need to get all that phenotypic and ecological responsive data to make sense of the genomic data. But, there's a pathway for being able to more efficiently characterize, get to know what's in a seed bank, and that could prompt greater use, but it requires the initial investment.
Yeah. What specifically are seed banks insuring us against, and have they really ever been put to use?
So I think this goes, seed banks, as what breeders would refer to as germplasm collections, right? Meaning that's the breeding material they're going to rely on. Yeah, absolutely, they've been used, right? In fact, they originate in being a tool for breeders, and they always have been. But I think you're asking a slightly different question, which is, have we ever turned to them in an emergency scenario where there's an environmental crisis and we need to be able to respond to, like a lethal necrosis in a crop or something like that, or the problems we're having with Cavendish bananas, right? So massive, yes, exactly, disease susceptibility. And I think that there are historically isolated cases of finding in the gene bank collection the landrace that has a trait that helps with addressing a very particular kind of crop shortcoming that we need to address. But I think it's really important to note that no accession from a seed bank can be plopped into place in, of a true landrace accession needs plenty of subsequent research and breeding to be developed into or put to use in a variety that's then used in contemporary agricultural production, right? So it's that is always going to be a pretty expensive and drawn out process. There was an earlier part to your question, though.
So there was, what are the types of insurance that these places actually insure us against, which you've sort of partially answered, I suppose, because you've talked about their use essentially for breeders to figure out what they can do in future. And I mean, the other use, which is the emergency situation type use, which doesn't seem to have happened quite as much. Are there any others apart from that, or have I characterized that really badly?
No. Well, so I think the one thing that I would add to that is that we've been talking about seed banks that are mostly sort of state-run or internationally managed big gene bank type infrastructures. But obviously, collections of crop diversity can come in different forms. And so you also have community seed banks or seed libraries. You have sort of middle range institutions that are not necessarily about long-term storage, but are about feeding diversity back into a particular region, for example. And so I think it's important to recognize that collections of crop diversity, even if they're not the big state institution, and maybe more often because they're not the big state institution, might serve much more direct and immediate needs, right, in terms of particular communities. So there are community seed banks in, for example, in Mexico. I'm familiar with some, and they were initially set up through the state, but seed banks that were community run where farmers could access them. So a farmer who, for whatever reason, lost their seed, a bad harvest, or some other reason, could withdraw a deposit, restart their agricultural production, possibly give some seed back to that seed bank in the future. And so that's an example that, you know, points in the direction that these sorts of collections of crop diversity can be truly influential in emergency circumstances, just not emergencies on the scale that we're often talking about.
National scale. It's almost like, I suppose, banking on the smaller scale when it used to be done by your local branch manager than it was by sort of HSBC or something like that. It's like, it's sort of smaller scale, but it has come up as an important thing in that context. Yeah. Slightly broader question, but with the challenges agriculture faces today and the changes it needs to make, do you see it as being able to overcome those challenges with relative ease in the grand scheme of things, or do you think that actually agriculture is in for an almighty shake-up over the next 100 years or so?
I hope it's in for a shakeup, I think. No, I don't think the transitions that we will go through in almost any domain will be easy if we're committed to resolving the climate crisis and instituting more socially aware and just institutions, both at the global level and at the regional or national level, right? I mean, that's going to require change that's not just about agricultural change. It's going to be about the things that we prioritize in as communities, as countries, right? Or even in our own lives. And so, yeah, I think one of the things that I think is often hard to navigate is that especially somewhere like the UK, there can be quite strong feelings about, well, we need alternative agriculture, right? You know, we haven't talked at all really about GMOs and the contests over GMOs, but there are significant camps that want to see us kind of throw away all the technologies that we have and go return to some idealized past that we can't return to. We are more people on smaller pieces of land, and we still want to have biodiversity too. So we need to use the tools of science. We need to use genetic engineering or gene editing to develop crop varieties that can do better than what we have now. There's, I think, no question about that, right? And so I think the real challenge is finding the space where all the people who want to do things different, the people with the gene editing tools who want to make crops that can be grown and allow greater sensitivity to our biodiversity needs, and the people who want greater diversity in the food system or social justice and equity. I mean, I think that they are the same groups of people, but they have different views about the roots that we get there vis-a-vis science and technology. And I think, creating the conversation that's at the middle of that, right? How do we create change and not not throw away the incredible knowledge and tools that we have. I don't know where that conversation is taking place, but I think that's the one that we really need to be having more of.
In the history of changes in agriculture, do those conversations take place in central places, or do they actually sort of resolve themselves just with, new stable points in whatever the structure is you're talking about, say like the agricultural structure, or the whether it be sort of financing or what people think about it, what they eat? Do they just find new equilibria? I'm thinking about this totally from a mathematical, I'm just going like maps and topologies and stuff like that, but maybe that's an oversimplification.
Yeah, I mean, to take a kind of wild case, we could totally transform the possibilities for the future if everybody ate less meat.
Yeah, but does that happen?
Right, does that happen? Well, 100 years ago, I wouldn't have been able to hold the position that I hold now, right? Because of assumed capacities about women. And so...
What does that mean?
So public ideas shifted really dramatically to make possible a kind of radical social change. Didn't happen easily, but it happened, right? And if we go back further in time, we used to... there was slavery in this country and many others. And that moral wrong was addressed, right? So we might think there could be a future time where we see eating meat as a moral wrong, and that a mass social transition could happen. And we might think it's morally wrong because of the ultimate consequences on climate. There might be other reasons that people see, but social opinion about
behaviors
and laws and legal structures, it does change, right?
I always think GMOs are a massive case in this. I mean, I could be totally wrong with this, but sort of putting my stake in the ground, I think that there will probably be a time in the future where we look back and go, why the hell didn't we do this sooner? And I think that's going to be the line that will take in future, rather than this is a disaster. But that's just me. That's what it's always important to have different people with different ideas. I suppose fighting it out in the space of ideas of what's going to work and not work.
Yeah. I mean, I think crises of various kinds will also precipitate change.
Yeah.
We talked about the desire for cheap food, but it may be that we cannot sustain its current levels of cheapness. And will that change what people eat when they have to spend more money on food? It almost certainly will, right? And so how do we respond creatively to new challenges as they arise? Crises also become points at which conversations can happen.
So actually, one more question on those lines. Are you the type of person that looks at the changes required as changes that will occur by evolution, or changes that will occur by revolution? Do we need to upend some things, or actually is this something where we will go and find a new maxima or minima? In terms of a stable point in, I suppose, the sphere of agriculture and farming in future.
I think it's too contingent on how rapidly the climate changes and what the trajectory of global population is, right? How many people do we have to feed, and under what conditions? And I'm sure there are researchers who know much better what those trends are likely to be, or what are they projected to be, and how able we will be to respond. But it is hard, from my thinking about things to say
which is needed without the context of the future.
how can you project a future context of stability under those circumstances?
Okay, yeah, no, fair enough. Yeah. Is there anything else that you think we need to cover? Or
No, that was great fun. I'm sorry.
I know, I've got to say thank you very much for taking the time to go over all of this with me. I think there's some really, really interesting perspectives or ways of thinking. One about the solutions that are potentially out there at the moment, and just about the trends in agriculture. I think it's such a fascinating area that is going to change so much. So thank you.
Oh, well, thanks for having me.
Thank you for listening to this episode of the Biotech Podcast. If you'd like to find out more about the show or the researchers we've been talking to, you can either check out the description on your podcast player or head over to our website at thebiotechpodcast.com. Thank you for listening, and please reach out with thoughts and comments about the show.